Hello viewer, you are watching Elim TV. Welcome to Form 1 Chemistry, Lesson 6. Today we are doing symbol classification of substances, and in our Lesson 6 we are going to discuss types of mixtures. Now, before we begin our lesson, I just want to ensure that you will be participating in this lesson by either sending your comments on the SMS number 22518. You can also use our Facebook page, Elim TV, and also follow us on Twitter at Elimu_KE. I'm your teacher, Benjamin K. Makanda. I hope you're going to enjoy this lesson. Now, let's begin by looking at the specific objectives of the lesson. In this lesson, we have specific objectives that we have. Now, by the end of this lesson, the learner should be able to describe the mixtures. You as a learner should be able to describe types of mixtures that we're going to discuss in the course of our lesson. So the key objective of the lesson is to be able to describe types of mixtures that we're going to discuss. Now, our lesson preview. Let's briefly look at the lesson preview. And the first one, let's review lesson 5. In lesson 5, we introduced the topic symbol classification of substances, and we focused our discussion on mixtures. And at that point, we also discussed and defined what a mixture is. We defined a mixture as a combination of two or more substances that are physically combined and they can be separated by physical means. A good example of mixture in this case can be maize and beans. If you take maize and beans and you put them together, you can still be able to get maize out of your mixture. And that one gives us an example of a mixture. We also looked at some of the ways in which we can actually help us be able to identify the best methods of separating mixtures. How you can come up with a method of separating mixtures. That's what we basically discussed in lesson 5. Now, in this lesson, we are going to describe different types of mixtures. As I've said, after we have discussed various types of mixtures, we will therefore move on and attempt some questions that will help us understand the topic even better. So I hope you're going to enjoy the lesson. Now let's begin our lesson by looking at types of mixtures. Types of mixtures. Now, mixture has at least two parts. An ideal mixture has at least two parts or components. So if you have a mixture, it will always have two parts or components. For example, if you take maize and beans, then you have two parts, a component that represent maize and the other component that represent beans. So that's why we are saying that a mixture has at least two parts or components, and these parts or components can be solid. We can have a mixture that is a solid. A good example of a solid mixture is you take rice and beans. So rice are in solid state, beans are also in solid state. So we have this component as solid as part of the component. The other component of mixture is liquid and liquid. Liquid. Now let's give an example of liquid mixture. Take water, mix with water. Then we have a mixture of water and milk. That one again is a liquid mixture. Then the last component or category of mixture is solid liquid. Mixtures can also be in form of solid or liquid. And in this particular case, you take a solid that does not dissolve in a given liquid. For example, if you take sand and put in water, sand does not dissolve. Then in this case, you're going to have a mixture that is solid liquid. We call it solid liquid mixture. So these are some of the components of mixtures that we want to discuss here. Now let's look at them in details, and we're going to have a flow chart that's going to help us understand this even better. Now, types of mixtures still. Now here we have our keyword mixtures are broad. And from the foregoing, we have just said that we have various components of mixtures. They are solid. We have liquid. We also have solid/liquid. Now, in this case, we have mixtures. Then the first component of this mixture could be, let's have a look at this. We have mixtures. Then the first component is going to be solid, liquid. Then the other one here have liquid mixture. Then the third one will be solid liquid. So out of this flowchart, we have to have solid liquid mixture. Now remember, liquid and solid liquid can further be subdivided to get other subcomponents in those categories. Now let's go back to liquid. Solid liquid mixture, they just exist the way they are, but liquid mixture can further be subdivided. So let's have a look at it. Now under liquid mixture, we have this one here. We have immiscible liquid mixture, and in this case, immiscible liquid mixtures are those liquids that when mixed, they form distinct layers. The two or more liquids that are being mixed, they don't form a homogeneous or a uniform solution. An example, you take kerosene, you add it to water. Now, considering that kerosene has a lower density than that of water, then kerosene is going to float on water. And in that particular case, the kind of mixture that we get is what we call liquid mixtures. Those mixtures that do not mix, they don't form a homogeneous solution. We call them immiscible liquids. So kerosene and water in this case are going to be immiscible liquids under liquid mixtures. The other category now is that of miscible liquids. Now, miscible liquids are those that mix and form a uniform layer, a homogeneous solution, a solution that does not have a distinct layer. A good example of this is water and milk. For example, if you take water and milk and then you're able to distinguish the two because they form a uniform layer. So such liquid mixtures, we call them miscible liquids. They're called miscible liquids. Now moving on to solid liquid. Under solid liquid, we also have two categories. We have those solids that when put in water, they will not dissolve. For example, if you take sand and put in water, sand cannot dissolve in water. And in this particular case, we have this. We're going to have soluble in liquids. So they are actually insoluble. And we've given an example of sand and water. They are insoluble. Then, on the other hand, we have this one here. These are solids that dissolve in water. Solids soluble in liquids, for that matter. Now, in this case, they are soluble. So, looking at the entire flowchart, you realize that mixtures can be subdivided into three components. We have solid liquid, solid liquid. Then liquid can further be divided into immiscible and miscible liquids. Solid liquid can take a form of solids insoluble in liquids or solids soluble in liquids. So this one gives us a summary of how mixtures can be categorized or be classified. Now, to further discuss this, we want to look at solid mixtures. So let's look at solid mixtures in details. Now, solid mixtures are mixtures or two solid mixtures are mixtures or two substances that results in a solid form. These ones we are saying they are solid mixtures. Solid mixtures are mixtures of two substances that result in a solid form. So that when you take solid mixture and you put them together, the outcome, the result forms a solid. If you take sand and mix with maybe gravel, at the end of the day you will get solid form. So these are mixtures after which, when you have mixed them, they will still form a solid form. A good example is sand. Sand is an example of a mixture with different solid particles. So we're just having an example there. The other example in this case that we can be able to highlight here is iron filings and sulfur. Is another example of solid mixture. Iron filings, they are gray in color, and sulfur powder is yellow in color. When you mix them, they are in form of solids. They form solids. So these ones, they are classified as solid mixtures. So still on solid mixtures, we now focus our discussion on iron filings and sulfur. Solid mixtures, and now we are looking at iron filings and sulfur. Now, iron filings are gray in color, while sulfur is yellow. so that when you mix them, you are able to form a distinction between iron filings and sulfur. So this is an example of iron filings, and then we have sulfur there. To the left, we have iron filings that are gray, then we have sulfur. So these ones, they give us example of solid mixtures. Now, to enable us understand how we can be able to separate solid mixtures, we want to look at a simple demonstrations in form of a video, which will inform our understanding of the separation of solid mixtures. So have a look at this video to help you understand what we have discussed further.
In this experiment, we will first make a mixture of black iron filings and yellow sulfur powder. Black iron filings and yellow sulfur powder are thoroughly mixed. They form a gray mixture of the two elements. This mixture can be separated by physical methods. For example, when a magnet is brought to the mixture, it removes essentially all the iron filings, leaving the sulfur behind, which here looks gray because of the impurities from the iron. The iron has been separated from the sulfur by means of a magnet. When the same mixture is heated in a test tube, the two elements iron and sulfur react together to form a new compound, iron sulfide. At first, when the mixture is heated, the sulfur melts. Eventually, as the heating continues, the iron and sulfur begin to react together. When the Bunsen is removed, the tube continues to glow as the reaction proceeds. The gray-black brittle solid formed is a new compound, iron sulfide. It is unlike either sulfur or iron and cannot be separated by a magnet.
Now, I hope you have enjoyed the lesson, the video. The demonstration has been very informing. Now, I want us to discuss briefly what we have just watched from the video to help us understand how we can be able to separate solid mixtures. Now, we are still looking at separation of iron filings and sulfur powder, and our discussion is based on what we have just watched in the video. So, separation of iron filings and sulfur powder. How do you separate iron filings and sulfur powder? In the first place, iron filings and sulfur is non-metal, is non-metallic. Therefore, that iron filings have over sulfur powder. One thing that we know about iron filings is they can be attracted by a magnet. Now, if iron filings are able to be attracted by a magnet, what about sulfur powder? They are non-metallic and therefore they can't be attracted to a magnet. So for this reason, we can therefore separate iron filings from sulfur powder by magnet method. Have you noticed that from the video that we have just watched? That iron filings are separated from sulfur powder by magnet method because iron filings are attracted, leaving behind sulfur. So that's very true. So this is what we say. When a magnet is held above the mixture, the iron filings are attracted and leave sulfur on the pieces of paper. That's very true, and we have observed this because iron filings are magnetic material, and because they are magnetic material, they get attracted to the magnet, leaving behind the sulfur powder on the piece of paper. And then you can be able to actually confirm that what is left behind is sulfur by looking at the color of the remnants on the piece of paper. The color is going to be yellow, confirming that actual sulfur has not been attracted but instead left on the piece of paper. Now, the next thing that we want to discuss, this is another classification of mixture, and this is solid liquid mixtures. We are now moving to solid liquid mixtures. Now, what are solid liquid mixtures? Now, solid liquid mixtures, there are two categories of solid liquid mixtures. And this one again, we looked at the flowchart. We can classify solid liquid mixtures in two categories. Those solids that do not dissolve in a liquid, and we call them insoluble. They form insoluble mixtures. And then we have those categories of solid liquid mixtures that dissolve to form a solution. And that's why we say there are two categories of solid liquid mixtures. Just before we go to the details of this, let's have examples of solid liquid mixtures in their two categories. In one category, I take sand, dissolve in water, put it in water, then sand is not going to dissolve. So in that case, we have insoluble solid liquid mixtures. On the other hand, I take sugar and put in water. Sugar dissolves in water to form a solution. Then that one is going to be a solid that dissolves in a liquid, and then we get a liquid mixture. So that's why we are saying there are two categories of solid liquid mixtures. So these are, in one category, the solid dissolves in the liquid, and that is said to be soluble. That's what I've just said. So one category dissolves. The other category, the solid does not dissolve, resulting to an insoluble solid liquid mixture. And we have given an example. Just to remind you, in one category, the solid dissolves in the liquid, and that is said to be soluble. The other category, the solid does not dissolve, resulting to an insoluble liquid mixture. In your own understanding and in your own free time, try to look at examples that fit in these two categories. One of the category in which solid dissolves in the liquid, and then in the other one where the solid does not dissolve in the liquid to form, and therefore it forms insoluble solid liquid mixture. Have an example in those two categories. But moving on, we now want to look at a flowchart that can summarize what we are discussing under solid liquid mixture. And this one leads us to this, still on solid liquid mixture. We have this now. So we are here, solid liquid mixture. That is the second category we are discussing. And we are saying they take two forms. The first category is this one here. They are soluble. We get that? Solid liquid mixture, then we have soluble. Then the second category, we have this one. Yes, they are insoluble. So that's why we're saying solid liquid mixture can be of two forms. Soluble, then we have insoluble. Are we together? Let's move on. Now we now still looking at solid liquid mixtures, and just to discuss what you've just watched or discussed from the floor there, is that in solid liquid mixtures, substances dissolved in liquids are said to be soluble. So if substances dissolve in liquids, then they are said to be soluble. For example, if you take sugar and you put in tea or in water and the sugar dissolves, then we say sugar is soluble. While those substances that do not dissolve are insoluble. An example is sand in water. It's not going to dissolve. We say it is insoluble. Still on the same, substances that dissolves in liquids, a substance that dissolves in liquid. For example, if you take a substance and you dissolve that substance in a liquid, then that substance that dissolves in a liquid is called a solute. And the liquid is called a solvent. I want to explain here. If you take sugar and you put in tea, then sugar is going to dissolve. So in chemistry, sugar becomes our solute. And the tea that dissolves the sugar becomes our solvent. Therefore, what is a solute? A solute is a solid that dissolves in a liquid to form a solution. So again, I've introduced the third term, solution. Now, I want to connect the three terms. We have a solute, a solvent, and a solution. Therefore, a solute is a solid. Our example, sugar is our solute. Then, because we are putting sugar in tea, tea becomes our solvent. Then, at the end of it, we are going to have a sweet solution, a sweet product. That sweet product is what we call solution. So solute, which is sugar, plus solvent, which is tea, you get a tea that is sweet. So we have solute plus solvent, you get solution. So solute is a solid that dissolves in a solvent, and a solvent is that solution, liquid, that dissolves a solute, while solution is the resultant liquid formed when a solute dissolves in a solvent. Are we there? Now, having discussed those three, we have solute, solvent, and solution. We can now have an equation that connects the three. So, and this is what we have. The resultant uniform mixtures is called a solution. That's what we have said. And as a result, we have this kind of equation. So here we are. Solvent plus solute, you get solution. And we said solvent. I want to use another example. Solvent is water, for example. Then solute, take salt. Then solution is maybe the stew that you form, or that soup that you have formed from what you are mixing. So solvent is a liquid, solute is a solid, and solution is the resultant that is formed out of the reaction between the two. Now we move on. How to separate sand from water? How can you separate sand from water? Sand is insoluble. Sand does not dissolve in water. And the water collected in the second beaker, so we are just looking at a way of separating sand from water. Sand is insoluble in water, and the water collected in the second beaker is not clean and contains small sand particles. And the way in which you can be able to separate sand from water is you take sand, put in a beaker, then to the sand add water, then allow the mixture to settle for some time. Sand being denser than water is going to settle at the bottom, while water will float on top of sand. Then the second thing that you have to do, you take another beaker that is empty and you carefully transfer the layer of water to the empty beaker, leaving behind sand. So in the process, sand remains in the first beaker while water is transferred to the second beaker. One drawback with this method of separating sand from water is that the water that is obtained is not pure, because part of the particles of sand, they also escape along with water, especially when they are very light. So this method of separating sand from water, we call it decantation. How do we call it? It is known as decantation. And decantation is also called sedimentation. We also call this method. So, are you able to describe what sedimentation is? You add sand to water in one beaker, then allow it to settle. Then you transfer the layer of water carefully to the empty beaker, leaving behind sand. So, that's what we call sedimentation. And now from this statement here, we are saying sand is insoluble in water, and the water collected in the second beaker is not clean and contains small sand particles which escape along with water. So the other thing that we have to say about this is that this method of separating sand from water is called decantation or sedimentation. Now, it is used in separating insoluble substances from liquids. Those substances that are insoluble, the one that cannot dissolve, are actually separated by this method called decantation or sedimentation. So the other thing that we have to note about this method is that the method is, however, not effective because some solids still have to pass into the liquids in the process of decanting. And we have said that they actually escape along with water. So the method is not effective. So we have to employ another method that can be used to separate this. So if we are not using decantation separation, then we use a more effective method of separation that we want to look at. So, and that one leads us to other methods used to separate sand from water. Other methods used to separate sand from water. What are other methods used to separate sand from water? So the first method we have is here. So we have a setup here. This setup is made up of a filter funnel, and this filter funnel is glass in nature. Then we have a filter paper. Then once we have this kind of a setup, we now separate sand from water. So the mixture is poured on top of a filter paper that has that is placed in a filter funnel, and then the particles that remain on the filter funnel are called solid residue, and then the liquid that seeps out into the second beaker or evaporating dish, we call it a filtrate. So from a filter paper and a filter funnel, we have residue remaining on the filter paper, and then the solution that seeps out is called a filtrate. Now, which kind of method is this? Filtrate, therefore, is filtration. So another method of separating sand from water is by filtration. Other than decantation, we can also separate sand from water by filtration. Are we there? Yeah, we use filtration to separate that. Sand collects on the filter paper. The solid that is left on the filter paper is called a residue. So that's what we are saying. Now, the liquid collected in the evaporating basin is called a filtrate. As we can see from the evaporating basin, this liquid is called a filtrate. And then, this method of separating sand from water is known as filtration. This method of separating sand from water is known as filtration. Just a small assignment for you. If you're making tea at home, sometimes maybe you're making tea out of you're using the tea leaves, and you want your tea that does not have the tea leaves. How do you get rid of the tea leaves after you've made your tea? So find out which method of separation is that. Then maybe you'll share with me in the next lesson how you can be able to separate the remnants of the tea leaves from your tea that you have just made. Which method is that? So that when we meet, you'll be able to tell me. On top of what I've just given you as a part of your assignment, then this is another assignment that you'll attempt for me. And you'll have to attempt this one here. State the most appropriate method you would use to separate the following mixtures. State the most appropriate method you would use to separate the following mixtures. The first one is sugar and water. When you mix sugar and water, which method are you going to use? Then the other one is kerosene and water, 2. Number 3, ethanol and water. Number 4, ammonium chloride and calcium chloride. Number 5, sand and iron filings. Then lastly, number 6, gasoline and diesel. This is what you are going to attempt. You will try it at your own convenient time so that when we meet, we'll be able to discuss this so that we are able to understand what methods we can use to separate these mixtures. So for your comments, clarifications, and maybe compliments, you can reach us on our SMS number 22518 22518. You can SMS your questions or comments and compliments. You can also use our Facebook page, Elim TV, and also follow us on Twitter at Elim_KE. Up to there, I've been your teacher, Benjamin K. Makanda. Until next time, stay tuned to Elim TV.